This is Greg Troutwine with Marine Technology TV, and we're joined today by Roland Boyson, the Chief Commercial Officer of Resen Waves, a company with a unique buoy to harness wave energy to power instruments at sea. Roland, this conversation was interesting for me because Resen Waves sits at the crux of what I consider a very important crossroad, and that's renewable energy and the emerging need to provide power at sea. To start, can you give us an overview of the Smart Power Buoy? Quite simply, how does it work?
Yes, and it is actually quite simple. We have the floater, which obviously carries the weight of the whole mechanical package. The floater is basically foam and glass fiber, to keep it simple. Then there's a shaft where you have the center drum. If you look at it, you see kind of yo-yo shape design, which is working as more or less as a pulley. It rotates on the shaft. Inside the cylinder, which is of course waterproof, you have the generator. That's kind of the heart of it all. You also have computer technology, Windows 10, and then worth mentioning, there's a very special spring. It's a carbon spring which is inside that helps keeping the momentum and making it very efficient, very responsive. And as a special thing, we have a unidirectional gear, and that makes the generator rotate only one direction. This way it won't lose momentum. If it would have to go, clockwise and then counterclockwise, you would lose a lot of momentum. But this ain't happening. It rotates the same direction all the time. Any movement, same direction. Then we have the mooring. The mooring goes all the way down to the seabed. That could be 10 meters, 20 meters, 200 meters, 2,000 meters. It's all possible. The mooring line is kind of special. It's a Kevlar armed mooring line, and inside this armoring you have, of course, the power cable, and you also have optical fiber cable. So on the seabed you have an anchor that could be a concrete block, it could be a sand screw, but you also have a large battery package, which is powered or charged through the power cable. And then on the seabed you can pretty much install all types of subsea instruments, docking station, whatever you have going. So that's the basic principle. If you look at the waves and you look at the Smart Power Buoy, it kind of makes an circular or ellipsoid movement, and the horizontal movement is actually 2/3 of the energy, and 1/3 is coming from up and down movements, vertical movements. So we have this yo-yo rotating back and forth, and because of the pre-tensioning in the mooring line, it becomes very responsive to even small waves like half-meter waves. It actually produces a fine output. It's extremely viable in the sea, also in the rough sea, in big storms with 10-meter waves. It's totally viable in such conditions. If it should get too rough, there's a warning 20-meter waves, crazy storms, you can actually submerge automatically or remotely. You can tell the device to dive just below the surface because of this tensioning mechanism we have built into the cylinder.
Now, when you look at the system as a whole, what do you count as one key technological differentiator for the smart power buoy that allows it to provide that efficient, reliable, clean energy?
As explained before, the pre-tensioning is actually an important feature. Then you have the unidirectional gear, so you don't lose the momentum in the generator. We have a very lightweight construction, weighing roughly 300 kilos. So these three factors makes it very responsive, very efficient. And if we are talking capacity factor, it's more than 50%. To compare that to something people can relate to, take a look at one of the big modern offshore wind turbines. They roughly offer 50% capacity factor. So that's how efficient our little device actually is. If you should compare further with a wind turbine, you can actually see our device as the nacelle. Because if you take the complete construction, you've removed the wings, the tower, the foundation. What do you have left? You have the nacelle left. That's actually what we have inside our cylinder.
You specifically mentioned that it is commercialized, it is working in the field. Can you give me a few more specifics on exactly where it is and what it's doing?
Sure. We have sold a handful of solutions so far. They're quite different from each other, actually. One I can mention is a coral reef restoration project in Bali. Actually, it's a trademark. It's called BioRock. And that is a way to restore damaged coral reef. It's very efficient and makes it very survivable compared to natural coral reef. And it needs power. It needs power to grow. So they actually have one of our smart power buoys deployed in Bali. Another thing I can mention, or another installation, would be the one in Hong Kong. It's a big Hong Kong company working in all sorts of industries and sectors, and they have this general idea, of course, about fighting climate change, trying to boost renewable energy in the city or Hong Kong area in general. So they have a vision of installing a huge wave energy park in the Bay Area to electrify most of the city. So far, it's only one. So there's still some way to go, but that's a great potential, of course, also. They're not in it for the real-time data. They're in it for the wave energy, for the electricity. Another one worth mentioning would be the Malaysian national oil company called Petronas, powering a subsea instrument suite. That would be another one. one point that I would like to point out is also we have a business strategy or an evolution strategy, you can say, product strategy, whatever. What actually happens when we double the size of the buoy? Well, it tenfolds the output. And if we double it again, it will tenfold one more time, and so on. Right now, it's roughly 2 meters times 2 meters, fairly small. But if you double it, you double it, you double it, you end up with having, you know, something like 20 meters times 20 meters, or maybe even bigger. And you would have, you know, an output that would be 100 times more or 250 times more. Depends on when you stop. Of course, there's an upper limit, but you can build a quite big buoy, and you can connect them to each other, like 10 or 20 along the coast or wherever you need them, and actually produce megawatts. Right now it's small, we know, and the output is small, but that's sufficient for all the instruments. But in the future, the next 5 years, 10 years, and so on, I'm pretty sure we will see that we will upscale the product just like we have seen with wind.
But if you had to really narrow it down to the top 2 or 3 industries or instances where you expect the greatest reception or the greatest prospects in the coming year, what would those 2 or 3 areas be?
Well, if I should be very specific when it comes to a certain instrument, I guess I would say ADCPs. Simply because we have a lot of ongoing discussions with customers specifically on these instruments, and it's also very common, very widespread instrument, so that would make sense. If I should, you know, take a more general approach to that question, I would say the whole autonomous, the whole unmanned trend that is booming nowadays, that will really also take us further. I'm sure about that. All the AUVs or USVs or drones, subsea drones, surface drones, airborne drones, they all need power. They all run on batteries, and batteries need recharging. If you can bring in also the real-time data connectivity, you really have something, right? So we see this whole trend, the autonomous trend, as a huge potential for our smart power buoy. That's for sure.